class, and we are taking a look at repository 7, which is an introduction to pandas. And everybody has cloned the repository. I'm going to go ahead and fire it up here in Jupyter Notebook. CD into, this is the wrong repository, CD into Python, and then CD into 07 for pandas. And yeah, I didn't get around to doing that this time. I just have solutions, which is under code. So we'll have to do some just working with blank Jupyter notebooks. So if you would like to have the code folder opened, we've got practice reading data and intro to pandas. I'll start up with number 1, practice reading data. And then I'll also have a blank notebook, which I'll call 01 class notes. So let me briefly walk through the solution code first, and then I'll go ahead and start the live coding. So this is pandas. Pandas is probably the single most popular Python library, certainly among data scientists and data analysts generally, people working with stuff on the data side. And if you've ever worked with Excel or CSV spreadsheets, you know that a spreadsheet is kind of your go-to tool or implement for working with any sort of flat file of data where you've got columns, those represent variables, and rows, those represent observations. Pandas is the Python library for working with spreadsheets, which in Python reference are referred to as data frames. And some people might call it Excel for Python, but it's actually way more sophisticated than Excel, in my opinion. Can do so much more, and it definitely feeds directly into even more advanced libraries that we won't see in this class for machine learning and predictive modeling generally, and more advanced statistics. But the purpose of this class, and really the purpose of this lesson rather, is to introduce you to pandas, to get a taste of it. And everything else in the class going forward from now up until November 7th will be pretty much exclusively learning to work with pandas, because there's so much to learn. And I know you've worked with it before, so this will be familiar to you. And you've gotten a taste of it for your app. But basically, once you're good at pandas, that is a whole job unto itself. That's a career, that's a field, which is data manipulation and analysis and visualization using the pandas library, plus its kind of auxiliary universe of other supporting libraries for visualization and stats and that kind of stuff. So we're going to shift gears at this point. We're no longer going to be working so much in directly based Python, that we'll continue to use all of those skills. And instead, this is sort of going to become a pandas class going forward. Though we will continue to do the Plotly Dash apps, they will start being Plotly Dash apps based on pandas data files from this point forward. So that's a quick introduction. And before we get into pandas, really the first step that one needs to get familiar with is how to read in a data set generally. So for that, it talks here about what's an import. We saw imports in last week's class, or maybe it was Tuesday's class, I can't remember, when I introduced you to virtual environments. And obviously we've been using imports a lot up until now in our Plotly Dash apps. We've got a new import this time around, import pandas as PD. So the rest of this will be the live coding, and I will add the comments in as I write out the blank Jupyter notebook. Let me get up my solutions answers here on the other screen. And obviously at any point, go ahead and stop me with questions or observations or clarifications. I guess one thing I should point out, which is in this repository we have code, but we also have a new folder that we haven't had up until now, which is data. I have a whole bunch of data files in here that are mostly CSVs, but there are a couple of Excel files in here. There's a table file. There's a couple of JSON files. And the purpose of this is to show that pandas is very robust at reading in a large number of spreadsheet or spreadsheet-like items. And we'll get a taste of that in this notebook. Make it big. All right, let's start with imports as always. We're going to import pandas as PD. And this should work because pandas is included in the base Anaconda distribution. If for any reason it did not work in command line, you would need to run pip install pandas. But I think that should run smoothly for everybody. Am I right? Okay, cool. All right. Try this. PD dot read underscore CSV parentheses quote dot dot backslash data backslash UFO dot CSV. And I have some Windows users. For a Windows user, you'll need to run the same thing, but you'll want to have it, whoops, as follows. You'll need to run, this is for Windows, put an R right here ahead of it, and you may need to flip or reverse the backslashes. So give that a go. This is again Windows, and this is Mac or Linux. That work for everybody? Are you seeing what I'm seeing? Okay, so we've got a data set now, and if we look at this, it looks kind of like, as I said earlier, an Excel spreadsheet. We have columns across the top: city, colors, shape, state, and time. We have rows: Ithaca, Willingboro, Holyoke, Abilene, etc. And then every row has a unique ID. So it's really formatted very similar to a spreadsheet. The difference is that unlike Excel, I can't actually interact with this data. If I click on Ithaca, nothing happens, right? If I click on colors reported, it doesn't sort. All of that, those things that you might be familiar with from Excel, now you'll be doing them with scripting in the cells. You'll be writing code to do the things that perhaps in the past you were very familiar with doing directly in the data in Excel. There is, and this is by design, there is no direct interface with the data in Pandas. Everything is going to be done in Python code. So this is a long output. We're just going to double click here in the output window in order to reduce it. And typically the first step in any Pandas analysis is to read in the data in this same way. But instead of simply reading the data, we assign all of the data to a variable. I'm going to call my variable UFO data frame, and I'm going to set it with an equal sign. And again, Windows will have to use the lower script. And then I run that, and I get no output, but I also get no error message. And now if I call my data set UFO data frame down here, it will give me all of the expected output. And if I just want to see the first 5 rows, I call head. Show the first 5 rows of your data frame. And this is a method. We've seen methods previously. We've seen string methods, we've seen dictionary methods, we've seen things like dot upper and dot lower. And all of that works because variables are objects in Python, and they will inherit any built-in methods or attributes that are appropriate to their object type. UFO data frame is an object type. What object type is our data frame? Type UFO data frame, and we see something new that we haven't seen before. In the past, we've seen string, we've seen integer, we've seen float, we've seen type dictionary or type list. This type is a pandas core frame dot data frame, which for short is called a pandas data frame object. It's a new type of object, and it has just a truckload of built-in out-of-the-box methods and attributes that can be used for data analysis. And the reason it's a data frame is because up here, when we first read it in, we instantiated it using the pd.read method. So head shows the first 5 rows of data, but what if I wanted to show something other than 5, like the first 3 rows of data? You just drop the number 3 into parentheses, and it'll show 3 rows, or 13 rows, or 130 rows, whatever you want, but it's always going to be the top. The default is 5, so you don't have to specify 5, but head just shows the first part of the data set. What about the last few rows? Oops, I need to stop doing that. If the top 5 rows are head, the bottom 5 rows are tail. And we can see here we have about 80,000 UFO observations. The latest is in Florida in September 5th of 2014. It was a burst of light. I looked at Tucson, it was a red and blue, Tucson, Arizona. Okay, so that's the last few rows. And again, if I want to see the last 4 rows instead of 5, then I use the dot tail method. And what if I just want a random sample of rows? Then I would do dot sample, and here I have to specify the number of rows. There is no default. So I'm going to sample any 3 rows at random, and it grabbed 1096, 74, and 42. And if I run that cell again, it samples 3 completely different rows. And I think that this is how this works. Random. It's been a while since I did it. Random state equals, we'll give it any number. We're going to go ahead and call it 42 because that's popular. And now, no, it is still doing it. Maybe you drop it inside there. I'll have to Google it to find the result. Yep, that worked. And now it comes back the same every time. So random state, I'm going to put those 2 lines of code side by side because this did come up in, was it Aiden's app? Was it yours? No. Who is it that had random data? Yeah, Max, exactly. Okay.
Does it once? It's a random generation.
Exactly. It does one random number generation, and then it will always come back with the same results in this lower set based on whatever the first random draw was.
42 could be any number. It's just
Yeah, it could be any number.
It's seeding whatever.
Exactly. That's the seed for the draw. And for what it's worth, if I close the notebook and come back later, it will still give me exactly the same sample. This allows your code to be reproducible in the future by other users. Okay, so we saw head, tail, and sample, and those are popular methods. What if I want to know how big is my data frame? The words data set and data frame are sort of used interchangeably, but data frame is actually the appropriate term. So the name of my data frame is UFO underscore data frame dot shape. Will tell me the number of rows and columns. And notice it doesn't have parentheses. It's not shape. That's the difference between a method and an attribute. It also has no options. This is, and I'll type it in here, rows and columns. What are the column underscore variable names? And copy the name of my data set. And here it gives them back to me as a list. City, colors reported, shape recorded, state and time, which corresponds to what we saw up here when we drew the head or the sample, right? Now keep in mind that in Python, the word variable is used kind of in 2 different ways. This is a variable, x equals 55, right? And then I call x, and that's x is a variable. We've used that a lot. But in pandas, columns are referred to as variables. So shape reported is a variable. And state is a variable, but they're not variables in the same way. Python variables are technically objects. This is referred to as variable assignment, but in fact what I'm doing is I'm creating a Python object of type integer. This is an integer type object, but shape reported is not a Python object. It is a pandas variable, also referred to as a series, and we can reference it as follows. Let me just put in some commenting. This is a Python variable, aka an object. Let's put all that together in one line of code. And this is a pandas variable, aka a series or a column. It's kind of referred to in different ways. And in this case, UFO data frame, bracket, quote, state. If I run that, it gives me all the state values. And if I put it under type, it shows that it's a series. So that's how you reference an individual column. But I'm getting too far down into the weeds. Let's just keep this kind of at a high level. Show me some high-level stats about my data frame. So I've got UFO underscore data frame dot describe is yet another method. If I run that, it'll tell me for my variables the count, which is to say how many non-null values are there. So we would guess that there's quite a lot of missing data in colors reported because it's got a much lower count than city. The number of unique values, there are only 27 colors, 52 states, because probably DC and Puerto Rico are in there, 27 shapes reported. But we've got a lot of different cities and quite a lot of different times because it's really down to the minute. The top, that is to say the most frequent in each category, so Seattle looks like there's a lot of UFOs getting seen there. A lot of UFOs are orange, a lot of UFOs are light, and a lot of them appear in California. But wait a minute, Seattle isn't in California. So how do I read this row? Does this mean that the most frequent occurrence is to see an orange light in the city called Seattle, California on the 4th of July? Is that how I read that row? Exactly, they're independent. So that can be a little bit confusing. What this means is the top or most frequent value for each one of these independent variables is what it's referencing. And then the frequency would be the of the top, the number of times that the top value appears. So this means that Seattle appears 646 times, and this means that on the 4th of July 2014, 45 different people saw UFOs. That's how you read this output. Okay, so at this point we decide our analysis is done. Now we want to save our results, right? Remember, back up at the top, we read this in as a CSV file. So now we want to output our results as a CSV file. Let's go ahead and call this my results. So I've got a variable Python object called my results. If I call it back down here in the cell, my results, and I run it, it comes back to me. And my results is also a pandas data frame. So I can save it as a CSV file, and I can give it the name /data my results.csv, and I'll want to specify index equal to false, because if I don't do that, then the index column over here would get saved as true, but actually I do want to save that on this case, so I'm going to leave that blank. And that should work. And if you run this, and then you go back over to your data file, under data, and you refresh, you'll see that somewhere under M, my results now appears. So that's our saved output. And that's the basic workflow, the basic ETL, or extract, transform, and load, at a very basic level. is we read in a CSV file, we did some analysis, we saved our results as an output CSV file. And that's really at the heart of what you'll be doing a lot of with pandas. Read it in, transform it, save your output in some way. So far, so good? Questions about what we just walked through?
Go back down to the export.
Yeah, definitely. And I will say, this ... /data/ my results, you can probably guess what this is doing. It's just like when you reference folders in terminal. ... means go up one folder. \data means down one folder, and then that's the name of the file. So where is it starting from? It's starting from the code directory, because that's where my Jupyter Notebook is running. If you happened to fire this Jupyter Notebook someplace else, then obviously this ... wouldn't necessarily lead you back to your data directory. All right, so let's try this a few more times. Let's try this some more, because in my experience, with Introduction to Pandas, my own instructor just went straight into a lot of pandas methods, and I was stuck with, wait a minute, how do I open some other data file other than this UFO data set that you're giving us? I just couldn't figure it out. So what we're going to practice now is we're going to practice reading in a bunch of different folder data files from a bunch of different locations. So you get the hang of reading in data, transforming it, and then saving it to some output place. All right, so let's try a new file. There's a file called hitters.csv in your data file. See if you can read that in. So for this one, you'd want to give it some new name. You might want to call it baseball or something like that. And you set that equal to, again, pd.read csv, quote mark ... /data/ hitters.csv, and then call back baseball.head, and hopefully you'll see something like that. Try the same thing. Describe your data. How did we do that one?
Space.
No, that would be, yeah, shape is also useful, but here I want the high-level statistics. Baseball.describe, parentheses, and here we see something a little different from the UFO data file. If I scroll back up to my UFO results, which I think, what did I do with those? Here we go, my results, I'll call this back, my results. I got count, unique, top, and frequency. And the reason why is because all of these variables, they're categorical. They're not actually numbers. Colors, city names, state names, even time, none of this is a number. So it's simply giving some simple stats that you could give about a categorical data. But the baseball data set is almost entirely numbers. At-bats, hits, home runs, it's all numerical. I think the only one that's not is, what have we got here? League, division, and new league. All of those are not categorical. So as long as there are some purely numerical values in my data set described as something different, it gives me the count, the mean, the standard deviation, the lowest and highest values named min and max, and then the percentiles, 25, 50, and 75% of my data frame. So we would interpret this to mean that in this data set, the average baseball player has 380 at-bats in a season. But there's some baseball player in there that actually had 687 at-bats. And I think this data is from like 1997, 98, so it's a little bit on the old side. And there's some unfortunate player who has, let's see here. Yeah, there's some pretty low stats in there. Certainly some people, maybe a pitcher with no home runs whatsoever. But anyway, this is describing high-level statistics about the data set, each of which you could call back as its own variable. So if I wanted to call back mean home runs, I could actually set that to baseball dot mean, and then I could call it back in a separate variable, mean home runs, and run that, and it is going to give the mean. Okay, this was actually not mean home runs. This was the mean of all the variables. I forgot about that. So this is simply the mean value of everything in the data set. Once again, suppose we wanted to output our results, output these results as a new CSV file. How would you do that? So this is your new data file. You'd set this equal to results, or whatever you want to call it. Let's call it baseball results, just to give it an original name. Run that, and then baseball results is a data frame. Baseball is a data frame, and baseball results is also a data frame. So bb results dot to CSV, and I'm going to call it /data /bb results.csv and run it, and it'll appear there with all of my other information. So much so that I could actually call it back. And I can call it back as new results using pd.read CSV, and then new results has got pretty much the same information. The only difference is that the index column is now being referenced as unnamed, and there's a workaround for that. But basically, we've extracted some data, we've transformed it, and we've loaded it back in as its own CSV file. Let's try a few more. Try a tilde separated file as follows. We're going to call this one, and it is, by the way, frequent to refer to data frames. You can call them with original names, but you can just also call them df. That's pretty common. df is going to be equal to pd.read csv /data /movie ratings.tsv. So notice that this is a tilde separated file, or maybe it's tab separated. I'm actually not sure. It's probably tab. Tab separated file is a TSV. And if I try and run that, because I'm using the read CSV function, this will actually work, but not in the way I expected it to, right? It's actually not breaking things up into appropriate columns. So for that to work, I have to specify the separator. The separator between rows is \t, which I guess is the escape character for tilde. And then I'll do df.head. And now it's clearly separating into different columns. But it's treating the first row as if it was column names, and that's because the default setting is to take whatever the first row of the data file is and call that the column names. This one actually doesn't have that, so I would need to specify the columns as follows. Columns is equal to a list, and I believe, if I remember correctly, I don't have this at my fingertips in terms of movie ratings. I've got this elsewhere, so I'm just going to make it up. I believe this is minutes I believe this is number of reviews. Might be the other way around, reviews then minutes, stars, and I forget what the long one is. I don't know, something else. And now when I run that, I'm going to delete this file. Or is it names? There we go. Sorry, it's names, not columns. Break that up onto a separate line. And now, rather than taking the first row of data as the name of my data file, it's taken the column names that I specified under the names function. And I could, in fact, have done this with the UFO data set as well, or the baseball data set. You can actually rename your columns this way. It's an easy way to give your data set new column names in the moment when you read it in. Okay, we're going to try a JSON file. Try reading a JSON file format. So on this one, we're going to call this df2. And if we try pd.read CSV and we do data \data yelp.json, we get an error message. You can probably guess why. We're using a method called read CSV to try and read a JSON file. Now CSV does have a number of options. It works well with the tab separated because there's just a clear separator, and actually you can specify any character here. The default is comma separation. So up here we could have said separator is equal to comma, and that actually would have worked just fine. But the default is comma, so you don't have to specify it. But JSON is something a little different. It's not just separating columns, but it's also separating rows in a funky way. So for that, we need a pandas read JSON statement. And we're still getting an error message because in addition to adding read JSON, we also have to indicate lines equal to true is the option on this one, and I'm missing some step here because actually that probably should have worked. pd.read JSON data yelp JSON. What is the error message? Trailing data. What did I do wrong here? That did work. I must have misspelled the word true. Let me do df.head, or just do brave, or just do sample. And here we see that we've read in a data set of Yelp reviews. It has the date, it has the review ID, the number of stars, and then some kind of comment. I think fate is delicious and great. A hipster shindig, great place to hang out, right? And if we run this again, because we're sampling, we'll get a different set of comments, right? Finally, another downtown lunch option, etc. And over here, votes is separated out into separate parts as funny, useful, and cool. So we could take a look at df2 votes, and we can see that it's a little dictionary. For each one of the comments, it's been rated with the number of votes, as this review was funny, useful, or cool. You know, standard kind of a Yelp thing.
So this is a file that you don't have.
Yeah, all of this is located in the data directory, which is part of the repository that you cloned and read in. But you can also read files directly from the internet as follows. And for this one, it's kind of a long URL, so I'm just going to slack it out, where you can also grab it from the solutions notebook. But here it is in Slack. Am I in general? I am. This is the data source. So if you want to copy this directly into your Jupyter notebook rather than having to watch me type it in on the screen, that is the wrong one. Class notes. Make it big. So first you define the URL.
Is the URL here is a variable? Or is that
Yes, I'm creating a variable.
just happens to be called
That-
URL?
Yeah, it could have been anything, right? My URL. And now we do df.3 is equal to pd.read CSV because it happens to be a CSV file. And then you simply tell it to read in my URL and df3.tail to the last 3 lines. And there we have it, the last 3 survivors on the Titanic. This is really useful, and you will, by the way, notice that this is actually just hosted on GitHub. You just post a file on GitHub and then use the raw.getuserhubcontent.com access link in order to send out your information. But it could be any CSV that is directly readable. Though I will say if it has to be downloaded, that's a little different. If you just take this and you drop it directly into your browser, you can see how that's formatted. It's actually machine readable in this format, which is why that works. But if I took that away, and that's
So how would you directly read the JSON?
You know, I don't actually know, but I know it's possible. I just haven't done it. But the point of all this is just to give you guys a sense, I don't want you to walk away from this feeling like I have to know how to read every possible type of data frame after my first pandas lesson. No, the point here is to give you the sense that pandas is very robust at reading a wide range of different file types, including Excel. And just with a little bit of sleuthing, you can quickly find out how to read the file type of interest to you. So on that note, let's also learn to find files on my machine. This is related to pandas, but not entirely the same. Import, let's see here. We're going to import 2 new libraries. Import 2 new libraries. And this is directly related to pandas. We're going to import OS, and we're going to, from pathlib, import a library called path. We don't have to spell import correctly. Okay, so you might wonder, what is my current working directory? Well, path.current working directory, or CWD, will show where my Jupyter Notebook is running. For me, I'm running in the code folder inside my 07 pandas repo, inside my general assembly directory, all the way up to my root, which is users. Yours will probably be similar, but will at the end, but different at the beginning. And this is a POSIX path, which means it is readable by different types of machines. Typically, if you just hard code this, the backslashes on a Windows machine, it won't read correctly, the same as it does on a Mac or on a Linux machine. But the beautiful thing about a POSIX path is that it's universal across all 3 major types of machines. It's readable by any of them without any changes to it. So path.cwd should work the same whether you're using a Mac, a Linux, or a PC.
Mine says Windows path.
Okay, I didn't actually know that, but I guess because you're on a Windows machine, so it was able to generate it. What's in that directory? So what are the contents of that directory that I'm currently in? Well, for this I'll want os.list here. Oh, I'm sorry, I meant to set this aside as a variable. So I'm going to call this my home dir is path.cwd. And then I do os list dir on home dir, and it'll show me the contents. There I've got all the Jupyter notebooks, including the one that I'm currently working on. And it looks like I also accidentally saved my CSV file to my code file a little bit ago. So what's the directory above that directory? Well, home dir we ran earlier is a POSIX path, or a Windows path. And because it's generated by the path library, it has an option called parent, which will show exactly the same thing, but one level higher. Let's try printing that so that we can compare the two of them. Print and also print home dir. So you can see the two of them are the same except for the code extension at the end. And you can keep that going. You can have the grandparent and the great-grandparent, and so on, all the way up until you get to root. So the parent option is pretty useful.
Hey, Austin.
Yes?
So is it pretty common to want to separate out your code from data files that you're importing in different directories than you have here?
The short answer is yes, definitely. But the long answer is it kind of depends on the project. For example, for our Plotly Dash apps, typically we have a very slim number of files. We have app.py, requirements, proc file, and then you might also have a data file in there. And in that case, it would be inefficient to have each of those files in their own directory, just have them all in home. But on a large project, I have a lot of Jupyter notebooks here, and I have like some 10, 20 data files. It is very common to separate them into two folders, yes. And certainly at work, that's how we always do it.
Mm-hmm. And then when you commit and push stuff up to GitHub, is it typically just the code, or you would include the files as well?
That's a longer question. It depends on whether you want other people to have access to your data or not. Perhaps you want them to have access to the data so they can replicate your results. Perhaps you don't because it's proprietary or it's PII, which is where the getignore statement comes in, right? That .getignore, if you don't want them to have your data, you create a folder called data, and then in getignore you simply put the word data, and it will ignore that entire folder. So that's the workaround that I typically use. Yeah.
So the hacker should have done that when she posted that AWS data, the Capital One hack.
Yeah.
She posted all the stolen data to GitHub. Someone found it and they
What's crazy about that story is it's almost like she wanted to get caught. You know, when you do something that sophisticated, when you're that good, how can you be so childish about covering your tracks? That seemed odd to me.
ask yourself that further.
Yeah. On the flip side, somebody at Capital One definitely lost their job over that sloppy encryption. All right, what's the directory above that directory? So we've used parent. And we'd like to know, where is my data stored? So for that, I would want to do homedir.parent, right? os.listdir will show me that there's a folder called data. And in order to access that, build a new path to your data folder as follows. Data path might be path dot, and this is new, join path, and it's going to join everything between commas. So it's going to join the parent and the word data. And then I can print data path. So now I've got a hard-coded, or not hard-coded, I've got a coded path to where my data is stored. What's in my data file? You can probably guess how I'm going to do this one. os.listdir. Oh, and I probably could have, yeah, I did get that a name. Data path will now list all of the files in my data path file, including ds.store, by the way. Does anybody know where that comes from? That's really pesky, and it only happens on Mac. Anytime you use Finder to transfer files, then a hidden file will be created in the new folder called ds.store, which allows Finder to undo data moves. When you use Control-Z to move it back again, that's ds.store getting called. So if you move files using terminal, this doesn't get created. But if you move them using Finder, you'll always have this pesky ds.store in there. So then you'll want to add that to your getignore. Again, put ds.store in the getignore so it doesn't end up on your GitHub. And everybody's like, oh, that's like your socks are showing. And if you really, by the way, if you really want to get rid of it after you committed it, git rmds store will remove it from GitHub after it's already there. That's just kind of like house cleaning. So finally, what's my data file? And finally, build a cast iron path to my data, right? So suppose I wanted to use UFO.csv. I might call this UFO path would be equal to all of this plus UFO.csv, and now I can read that in. Now I can read that using pandas. df is equal to pd.read csv UFO path, and this is how the pros do it. So that you've got this really short and efficient path that isn't hard-coded in. A very frequent mistake is to do this, and I've seen this unfortunately a lot, and I did it myself a lot back in the day, right? df equals pd.read csv quote backslash ufo.csv, right? And this actually works for me. This works just fine. If I go ahead and I write that in and I do df.head, hey, there it is, beautiful, right? What's the problem with doing it this way, this hard-coded file path? Can you guess?
Change the path.
So a number of things could happen. Definitely if I rename any one of these folders, suppose I don't want it to be called Austin Lassiter anymore, I want it to be Austin Lassiter 2, the whole thing will break. So any change to a higher level folder will trickle all the way down. That's a serious problem. The other serious problem is, what if I send my code to GitHub and somebody else clones it? Not only do they see that I have funky named folders in my computer, but this won't run for them because your computer doesn't have a user named Austin Lassiter on it. So using hard-coded file paths is a big no-no and very much a newbie mistake when you start using pandas. Much more efficient is to use the shortcut like we did earlier, and that works just fine. That's a nice shortcut. But if you really want to do it the professional way, you'll use path.joinPath. And what's nice about this, by the way, if you get used to doing it this way, this is nice, it's short, it works. But suppose you have to read in a whole ton of files from a folder because you've got a project that it's ongoing and it's constantly reading from the same folder. You would have to change this hard-coded, even though it's got the double dot, you'd have to change it for every one of the files. If you use path.joinPath, then you can write a function or a for loop that will iterate through all possible files in the directory, even as they come and go. It will still capture all of them. And you can even do stuff like using a wildcard character in there as well to read in everything that's a CSV. So that's the advantage of using the path way of getting into data. And I thought maybe I would end with an example of that. We are at 8:28. But I'll just do a quick example of that. For file in os.listdir, what did I call it, data path? Print file, right? And a data path. What did I call that one? Maybe we had an underscore in it. Okay. Oh, right, because it's a variable, it's not in quotes, of course. So I can print all of those files, but I could also do this. df is equal to pd.read csv file, and then print df.columns. Right, only CSVs. For file if CSV and file. So we could do some troubleshooting for the ones that aren't CSVs. File. What am I doing wrong? Does not exist. So a couple of them have funky file names. Let's try. That's because I've got too many in here. and then accept. Accept, pass. This is what I get for doing this live. Okay, there's too many different file types for me to quickly do this briefly, so I'm sorry I wasn't able to give a demonstration of it here live, but I think you guys get the idea that what you could do with a shorter list of files is write a script that would open up each one, do something in pandas, like a quick describe or a quick list of columns, and then save that as an output. And you automate what you had been doing manually in Excel prior to that time. I'll try and have a good example of this pre-written for next night's class. But what I do want to communicate is this just makes what used to be a very tedious manual task done in Excel very efficient and automated. So let's go ahead and stop there. Thanks for the great presentations in the first half of tonight's class. Really excited about that. Have a great weekend, and I'll see you guys on Tuesday of next week, okay?
I won't be here on Tuesday, just a heads up.
Okay,
Continue to remind you, but if you could record it, that would be.
happy to. If you
Fabulous.
send me a reminder,
I will.
that'd be helpful. But yeah, happy to do so.
Thank you.
Have a great weekend.
Have a good one.
That's right. See ya.
Thanks.
See ya.
You made it in time for the 8th inning on.
Yeah, I got there in the third. I got there just in time for Trey Turner's home run. Good night. I just got in as the whole crowd was cheering, and that was really, it was just contagious. And the stadium was packed. Basically, from the bottom of the 7th inning on, people were on their feet the entire time. It was so exciting and so dramatic to see them come back from that deficit.
Yeah, that's awesome.
Yeah.
So, are you going to either of the or any of the Dodgers games?
I'm thinking about Sunday. I just dropped money on that one.
Yeah. Do you have season tickets?
No, not at all. Not at all. And when I go, I get nosebleeds.
Yeah.
But it's just fun to be there. How about you? You think you'd go to India?
No, I mean I'm not a big baseball fan or a big national. I'm a